see what is there in the ray optics. Starting with the concept of refraction. This is the first concept of ray optics. And when you deal with the concept of refraction, you know, the first thing is when light will travel from one medium to other, there is bending of light from its original path. If this is rarer and this will be denser, then it will move towards normal. If this angle is I and this angle is R, then the most important law, which is called Snell's law, is sine I upon sine R, which must be equals to C by V, and you call it mu. This is for rarer to denser. But here when you will take from denser to rarer, this becomes sine R upon sine I. That should be equals to V by C, and we call it again mu. So if you will be calling it from rarer to denser, here you can write it from denser to rarer. This is the first important concept. Just recall करते हुए सारे numericals के साथ में आप सीखेंगे सब चीज को, but this is the first concept, refraction. Number 2 concept. If you just visualize these two expressions, you can clearly see 1 mu 2 is always equals to 1 upon 2 mu 1. देख सकते हैं आप C by V and V by C is there. So the product of 1 mu 2 into 2 mu 1 is always equals to 1. Never ignore this concept. Concept number 2. Logic is here only. Now see number 3. When we have multiple media, like 1 mu 2, 2 mu 3, 3 mu 4, then it should be equals to 1 mu 4. Intermediate media सारे गायब हो जाते हैं. First और last media ही attack करता है when you have multiple refraction. So 1 mu 2, 2 mu 3, 3 mu 4 is always equals to 1 mu 4. Like this, 1 mu 2, 2 mu 3. It can be written as 1 mu 3. अब इसमें से अगर आपको बीच में से कोई भी गायब है तो वो बड़े आराम से आप कैलकुलेट कर सकते हैं. So for numerical purpose, this result is really very important result. Number 4th concept is when you will take glass slab, a ray of light, when passes through it, must passes like this. But when it passes through glass, it refracts towards normal, and then again when it will come out, it will move parallel to this. This relation or this distance is called d, we call it lateral displacement. They must be parallel. To find expression for the lateral displacement, starting from this angle, this is angle I, this must be R. So the remaining angle should be equals to I minus R. A, B, C और N, 4 पॉइंट हमने यहां पर दे दिए. बाय द वे थिकनेस इसकी T दे रखी है. पहले आप cos R निकाल दो. Cos R is base upon hypotenuse. One. फिर कैलकुलेट करते हैं अपन sin I माइनस R. Perpendicular upon hypotenuse. यहां से AC को लूं और अगर मैं यहां पर रख दूं, so your D becomes AC sin I minus R. AC can be written as T upon cos R. This is concept for lateral displacement. T upon cos R sin I minus R. Concept number 5. The ratio of real depth to apparent depth is equal to refractive index mu. Here it is. The object lies here. I'm calling this to be O. This is actual depth. But if you will visualize from a different angle, then because of denser to rarer, it bent away from it. Looks like that the light is coming from this point B. So AB is your apparent depth. अब यहां ध्यान रखिएगा, ये है नॉर्मल, यहां से लाइट गई, so this must be I. इसका मतलब this angle must be equals to I. This is R, so this angle must be equals to R. I और R को बहुत अच्छी तरह से डिफाइन किया, I, R. Sin I perpendicular upon hypotenuse. Sin R perpendicular upon hypotenuse. So if you will take refractive index mu, because of denser to rarer, sin r upon sin I. sin r की वैल्यू रख दी हमने a n upon b n, sin I की वैल्यू a n upon o n. a n से a n तो कट गया, what you are getting is o n upon b n, which is approximately equal to o a upon a b. o a is actual depth or real depth, and this is apparent depth. So here it becomes apparent depth, real depth upon apparent depth. Very, very important result. Prove that real depth upon apparent depth is equal to mu. This is the result. How real depth and apparent depth are equal. The difference of real depth and apparent depth is called shift. So here the next concept is what will be the apparent shift. Apparent shift must be equals to real depth minus apparent depth. AB can be written as OA upon mu. OA you can take out 1 minus 1 upon mu. This is apparent depth. अब by the way हम जनरली इसको T से बताते हैं जब भी हमारे पास में ये चीज आती है. कभी भी apparent shift अगर पूछा जाए तो आप सीधा सीधा लिख सकते हैं that what is this apparent shift? You will write apparent shift is equals to T 1 minus 1 upon mu. देखते हैं नंबर 7 तक. What will be apparent shift in multiple media? ये बड़ा आसान सा फॉर्मूला है. apparent shift equals to T1 1 minus 1 upon mu1, T2 1 minus 1 upon mu2. Similarly अगर n मीडिया है जिनके अलग अलग रिफ्रैक्टिव इंडेक्स है तो आप इस रिलेशन से इसको लिख सकते हो. Like this. A coin is here. These three are three liquids of refractive index mu1, mu2, mu3 having T1, T2 and T3 as their thickness. So what will be the shift of this coin in this glass? This you can simply explain with help of this. T1 1 minus 1 upon mu1, T2 mu2 and T3 1 minus 1 upon mu3 and so on. Apparent shift in multiple media. Number 8. Refraction is optical phenomena in which wavelength of light will change Second, velocity will change. Third, amplitude will change. Fourth, intensity will change. Then which quantity will remain same? You will say it is only the frequency that will remain constant. So in the phenomena of refraction, optical phenomena, all other parameters will change except frequency. Apparent shift in position of sunset and sunrise is due to refraction. The atmospheric refraction will take place, and as a result, there will be delayed in the sunset. Like if this will be Earth and this will be the atmosphere. So due to refraction of light, actually sun is here, but it looks like that sun appears here only. So it is visible before sunrise and it is visible after sunset. The reason is this only, which is the apparent shift in the position. Tenth concept is, as we discussed, Snell's law says mu equals to sine I upon sine R. That is equals to C by V. As you know that the frequency will remain as it is. So the formula of refractive index can be explained in terms of wavelength in this mode. Lambda upon lambda dash is also equals to mu. Refractive index is say 1.5. It must be unitless, must be dimensionless. We want to find out what is velocity. Now velocity should be equals to C upon 1.5. Any medium having refractive index 1.5, what will be velocity? Directly रखेंगे अपन 3 into 10 raised to power 8 upon 1.5. So this becomes 2 into 10 raised to power 8 meter per second. You can also equate these two expressions as mu is C by V and also equals to real depth upon apparent depth. So the apparent depth can be written like this also, real depth upon C into V. Like real depth in the medium is given as 20 meter. Velocity in that media is given as 2 into 10 raised to power 8 meter per second. What will be apparent depth? अब डायरेक्ट लिख सकते हैं अपन 20 upon 3 into 10 raised to power 8 into 2 into 10 raised to power 8. This will cancel. You can write 40 upon 3 is real depth as apparent depth. So these are just the introductory concepts of refraction, that what is basically, the basic concepts of refraction. If you will see, you find out that there are various small formulas. If you will remember this, it is very easy for you to solve the numerical problems of ray optics in this manner.